Okay, to work on a problem like this, where we have the sine of 2 times something inside there, we're going to have to use the sine of 2 theta equals 2 sine theta cosine theta, which is the double angle identity. Now, in order to do this, the first thing we got to do is figure out what angle, that's what this arc sine means, that's what this inverse means. What angle is going to give us a tangent equal to x? Well, keep in mind x is the same thing as x over 1. And for this problem, it says that x has to be positive. Well, if that's the case, then we're going to be working in the first quadrant. And here, we're just going to draw a triangle in to represent this angle. It's not exact. We don't care about scale. We're just trying to get something to kind of visualize this. So what's going to happen whenever you have the tangent is x over 1, we need to remember about so, ka, toa. And keep in mind that these are all division. So, since we have the tangent, we know the tangent is the opposite over the adjacent. So we have the opposite over the adjacent. If this is our angle theta that we're looking for, the opposite is x, the adjacent is 1. Now to use our double angle identity, we have to find our sine. Well, in order to find our sine, since sine is opposite over hypotenuse, we need this hypotenuse. And since this is a right triangle, this is our hypotenuse, we know it's going to be a squared plus b squared equals c squared, or x squared plus 1 squared equals this side squared, or this side is the square root of x squared plus 1, because 1 squared is 1. So now we can find our sine. Since sine is opposite over hypotenuse, we're going to use the opposite x over hypotenuse, square root of x squared plus 1. We also need our cosine, and the cosine is the adjacent over the hypotenuse. So cosine equals 1 over the square root of x squared plus 1. So we've got those. Now we just need to plug it into here. So we have the sine of 2 theta equals 2 sine of theta is the x over square root of x squared plus 1 times cosine of theta, which we found to be 1 over the square root of x squared plus 1. So if we multiply across the tops, we end up with 2 times x, which is 2x times 1. And when you multiply the bottom, anything under radical times itself, it just cancels out the square root, so we end up with x squared plus 1. So our solution is going to be 2x times, or 2x over x squared plus 1.